Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. We are presently studying marine boilers. Today we have 28th lecture and the topic is causes of boiler troubles due to contamination of boiler water. An important reason for boiler troubles is due to incorrect water treatment. During this service, boiler water can become contaminated due to impurities entering into the boiler feed water. These impurities can include salts from seawater, lubricating oil from machinery, or oils from leaking heating coils. Dissolved oxygen can also cause corrosion in the boiler. Effect of these impurities are discussed in the following slides. First of all, we will see the composition of salts in seawater. Feed water used for the boiler on ships is usually evaporated from seawater, which may contain negligible salts. However, feed water system can become contaminated with salts through leaking condensers or priming of evaporators. Average seawater contains approximately 32,000 ppm of total dissolved salts with approximately following composition. First one is sodium chloride with 25,000 ppm. Second is magnesium chloride with 3,000 ppm. Third is magnesium sulphate with 2,000 ppm. Fourth is calcium sulphate with 1200 ppm. And lastly, we have calcium bicarbonate with 200 ppm. Now we will also see the composition of salts in groundwater. Analysis of average groundwater sample is given below, which consists of number 1 sodium chloride 50 ppm, number 2 sodium nitrate 35 ppm, number 3 magnesium sulphate 30 ppm, number 4 calcium sulphate 90 ppm, and number 5 calcium carbonate 200 ppm. Only evaporated water should be used as makeup water for boiler feed, as ordinary shore water contains enough salts which exceed the maximum allowable limits prescribed by boiler manufacturers. Shore water may only be used in smoke tube boilers, that too in extreme emergency. Now let us see the effects of sodium chloride in boiler water. Firstly, the solubility. Sodium chloride is highly soluble in water and does not come out of solution under normal boiler condition. The density at which sodium chloride comes out of solution increases with increase in pressure and temperature. Second is the causes: foaming and priming. Heavy concentration of sodium chloride can cause foaming and priming. High water level in the boiler may aggravate the problem. Let us see its chemical reaction. Sodium chloride in conjunction with magnesium sulphate forms sodium sulphate and magnesium chloride as shown in the reaction here. Sodium sulphate formed in the reaction is harmless and remains suspended in water, whereas magnesium chloride formed starts the corrosive cycle and must be eliminated by suitable treatment. Let us see the effects of magnesium chloride in boiler water. First of all, about its solubility. Under normal condition, magnesium chloride is soluble in water, but it can be broken down to hydrochloric acid and magnesium hydroxide as per the following reaction. Magnesium hydroxide provides alkalinity. It has low solubility, thus it can deposit and form scale. However, with suitable treatment, it can be precipitated and removed by blowdown. In this reaction, hydrochloric acid can cause corrosion in the boiler. You can see the HCl combines with iron form ferrous chloride and hydrogen. In the subsequent reaction, we can see this ferrous chloride recombines with hydrogen, forms ferrous hydroxide and again forms HCl. Hydrochloric acid is regenerated by further reaction which continues the corrosive cycle. Now let us see the effect of magnesium sulphate in boiler water. First of all, let's see its solubility. Magnesium sulphate in small concentration is soluble under normal boiler condition. It is responsible for scale formation. When its density is high, it may come out of solution and deposit. Scale is formed which affects the heat transfer. It has the chemical reaction which we have seen earlier. Magnesium sulphate may combine with sodium chloride, thus forming magnesium chloride and sodium sulphate as seen in the reaction earlier. Now this sodium sulphate formed in the reaction is harmless and remains suspended in water, whereas magnesium chloride formed starts the corrosive cycle and must be eliminated by suitable treatment. Coming to the effects of calcium sulphate in boiler water, let us see its solubility. With increase in temperature, solubility of calcium sulphate decreases and it will thus be deposited in the form of crystal ring as water becomes supersaturated locally with these salts. It is responsible for scale formation. Calcium sulphate is most dangerous compound which can form a hard tenacious scale and affects the heat transfer rate greatly. This can result in overheating and subsequent failure of heating surfaces. The mechanism of scale formation is very complex. When steam bubble is formed on heating surface, the plate under the bubble becomes overheated because it is momentarily insulated from water. The water containing the salts in solution in contact with the plate around the periphery of the bubble also becomes overheated. When the bubble bursts, water coming in contact with overheated plate will be locally overheated again, thereby causing more deposition. Let us see the effect of solubility on scale formation. Thus, it can be generally stated that those salts whose solubility decreases with increase in temperature will form scale on heating surface and sludge on cooling surface. Salts whose solubility increases with increase in temperature do not normally form scale upon heating, but sludge may be formed if their saturation point is reached. Let us see the effect of calcium bicarbonate in boiler water. Calcium bicarbonate is decomposed when heated, liberating carbon dioxide and permitting precipitation of calcium carbonate. The effect of calcium carbonate is calcium carbonate has low solubility which decreases with increase in temperature and thus forms scale. Scale formed by calcium carbonate is soft and porous in nature and is not a very poor conductor of heat, such as calcium sulphate scale. Effect of carbon dioxide. Carbon dioxide liberated in the above reaction is responsible for formation of carbonic acid, thus lowering the pH of boiler water. Effect of calcium in boiler water. Presence of calcium in boiler water results in loss of alkalinity, corrosion of boiler metal surfaces and loss of phosphate reserve in the boiler. Now let us see the causes of corrosion and its prevention. First one is electrochemical corrosion. When iron is in contact with water containing hydrogen ions, electrochemical corrosion similar to the battery reaction may start and metal may start corroding. To prevent electrochemical corrosion, boiler water should be alkaline with no dissolved oxygen. Second is inefficient filtration. Over lubrication of reciprocating steam machinery and inefficient filtering of feed water may contaminate the boiler water. Animal and vegetable oils decompose into fatty acids causing corrosion. To prevent corrosion, pure mineral oil is used. There are very few machinery where lubrication is required. And the presence of dissolved oxygen is also responsible for corrosion in the boiler. Presence of dissolved oxygen causes corrosion in boiler. It is removed from water by mechanical and chemical deaeration. This completes the study about contamination in boiler water and their harmful effects on boiler. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. This book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the students in preparing for the exam and also to work on ship's boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.